Welcome back to the Cave of Science, and today we're going to look at the periodic table, periods and groups, and what constitutes a period and what constitutes a group. So periods or rows, they are horizontal on the periodic table. In other words, they run from left to right, and there are 7 of these. And as you start a new period, you're filling up a new principal energy level or shell with the electrons. And also the number of orbitals increase as you go down the rows or go from top to bottom on the periodic table. In chemical periods, you can see the period number, the number of orbitals, there's just going to be 1, and the number of elements that are located there. And you can go all the way down to period number 7. It has 7 orbitals, and the number of elements located in that particular period are going to be 32. So if we look at a periodic table, you can see over on the left-hand side here, period 1 has our 2 elements, period 2, period 3, and so forth. We're going to come back and talk about why the lanthanides and the actinides are not in the periodic table, but really it was a matter more for convenience. So again, we look at periods running from left to right, and you can see that there are 7 periods. One other nice thing about the period, you also know what energy level they're filling up and what orbital. So in the first period, we fill up the 1s with 2 electrons, and so we have hydrogen and helium. So we get on our second period, we fill up the 2s, 2p. You go down to our third period, we fill up the 3s, 3p. And then we just keep following Hund's rule. And if you remember Hund's rule, it's the 1s, it's the 2s, 2p, 3s, 3p, 4s, 3d, 4p, and so forth. And these elements start filling up in the same order. So if you start looking at these 2 columns here, you can see that the s are always being filled. And here you can see that the P's are being filled. So you know a little bit about the periodic table, you can pretty much tell what energy level is being filled. Now groups, you're going to hear the term family too, but we're going to come back and take a little closer look at families. But the groups are vertical columns on the periodic table. And there are 18 numbered groups based on similar or chemical characteristics. And these groups are based on a similar outermost electron orbital structure. And each group has the same number of valence electrons. And this is the important part here with the valence electrons. And we're going to look at, I'm going to call them the big 8. And we're going to look at these on the next column here, or next slide here. And you can see we have group 1, group 2, and we go all the way to group 18. Now, different periodic tables are going to name these differently. So you could see this could be called 1A, 2A, 3A, 4A, 5A, 6A, 7, 8, where group 18 would be 8, 8A. And usually these are written with Roman numerals. And so we're going to look at these because those, the big 8, you can really tell a lot about the number of valence electrons by knowing what chemical group or family they're in. So as an element, family is a group of elements with similar properties. And we're going to look at, again, families a little bit closer in our next video. The elements in these families have the same outer electron orbital structure. From this, we can determine the number of valence electron. Well, what's kind of nice, anything in group 1A has 1 valence electron, and if you remember correctly, elements like that be stable, so they're either going to lose electrons, enable a stable configuration, or gain. If you're in group 2A, you have 2 valence electrons, so it's going to lose those 2, so you can have a 2+ charge. Group 3A, 3 valence electrons, and you're going to form a 3+ charge. Group 4, which starts with, you have carbon in this group, you got 4 valence electrons, So you're not going to lose 4, you're not going to gain 4, but you're going to share or form covalent bonds. Group 6, when you get down to group 5A, you got 5 valence electrons, so it's going to want to pull in 3 more, so it's going to form a 3- charge. You can figure group 6 has 6 valence electrons, group 7 has 7 valence electrons, so it only wants to take in 1 more. And when you get to group 8, it's got valence electrons, and that fulfills the octet rule, so it's a very stable configuration. And a couple credits here from our pictures. So we're going to look at families and some other characteristics of the periodic table on the next slide or the next video. Thank you.